Hello everyone, welcome back to the next lecture of our blockchains course. So you've now got a good hands-on experience on what Fabric is, how to use Hyperledger Fabric and so on. In the next two lectures, we're going to see another very interesting Hyperledger project called Hyperledger Composer. And this is primarily intended to help developers, business users to create blockchain applications in a very simple and intuitive manner. Today with Hyperledger Fabric, you actually need to understand a good deal about how Fabric is architected. You need to understand ordering service, peers, the certificate authority, MSPs. You need to understand identities, you have to work with certificates, you have to have digital signing. There are a lot of complexities in there that only an experienced developer might be comfortable with. It takes a little while to get a hang of all of these concepts. Hyperledger Composer wants to make all that process of development a lot easier for you, development and management of your blockchain network. So it's really targeted towards business users. The emphasis is on developing a business-centric vocabulary to define what your blockchain is going to be. So you're going to be defining your smart contract in terms of models. You're going to model it in terms of assets. So instead of thinking of low-level variables, data elements, you're going to be talking in the higher level business assets. You will be talking in the notion of participants. You don't have to work with certificates anymore. And you'll be talking about business logic or business transactions. So all of that is abstracted one level up for you to define your blockchain network. And this, we hope, will significantly reduce the risk of development and the fact that it takes a long time to develop some of these applications and can be fairly complex. It also increases understandability and flexibility. So when you see a composer code, then you can easily understand what this code is trying to do. And you're not working with a very low-level programming language like Golang or Java. Now, what are some of the features? Like I mentioned, it helps you model a business network, and it also helps you test and expose via APIs. So Composer has a way to automatically generate certain APIs based on the assets that you define. And applications can invoke transactions to interact with the business network. It also provides some support for integrating your existing systems, your organization's internal systems, with blockchain. This is fully open source, it's open governed, and it's part of the Linux Foundation. It's under the Hyperledger project itself. It's another project in Hyperledger. The current implementation of Composer works on top of Hyperledger Fabric. So there is a Hyperledger Fabric network that you've set up, and Composer allows you to do application development at a higher level, business level, compared to what Hyperledger Fabric allows you to do. But it is possible that in future, Composer could connect to other blockchain platforms as well. Today, it only connects to Hyperledger Fabric. That's what is shown in this picture. There's a business application, there's a Composer layer, and then there is Fabric. So today, it connects only to Fabric, but in future, it could connect to other platforms as well. There is a very easy to use web browser playground. So you can go to the playground, you can start playing around with it. You can get a feel for what application development looks like in the Composer world. And the same code you can actually, download the code, set it up yourself and create a playground just for yourself. So that is also possible. So what are the main goals of Composer? Why did we create this? It is to increase understanding of business applications. So you can think of coding your smart contracts from a business context. You can hopefully save significant amount of time in the development process itself. It helps you reduce risk because now your coding is a lot simpler. It's not have to deal with the nitty-gritty details of Fabric, and it hopefully also increases your flexibility in how you abstract your concepts, and it makes it easier to iterate. So you can improve upon your code fairly easily. So Composer has been developed using a fairly extensive open development toolset. These should be very familiar to you if you're a JavaScript fan. So it's entirely written in JavaScript. So there is a custom modeling language. It's again very intuitive to use. It models notions of assets, participants, and transactions. We'll talk about that. We'll talk about some of the business logic that can be written in JavaScript and that can be run as part of your smart contracts. So we'll talk about that. There's a web playground that you can play around with and understand how to create applications. There are a couple of libraries, client libraries, Composer-client, Composer-admin, that you would use to connect your blockchain application to the Fabric network. And these are provided as NPM modules. For a couple of very prominent, highly used editors, there is support for writing your Composer applications in them. So we support Atom and Visual Studio currently. There could be others in the future. CLI utilities are provided, so you can invoke Composer commands directly using CLI, and there is of course APIs as well. And Composer also gives you the ability to generate code. So this is specifically for people who want to quickly generate a user interface for their application. There is Yeoman, it's a popular tool for code generation. So based on how you have defined your assets and modeled other things in your network, you can automatically generate code that can be connected to a user interface. And it also follows existing standards with Loopback and Swagger to connect your existing systems and access the data through them. So it provides an easy way for you to generate a set of APIs specifically for your application, and then you can use your APIs in other applications. So we look at some of these concepts in a little more detail. So there are multiple user roles in a blockchain, right? So there is a network service provider, so the one who runs the network itself. There is a consumer of the network who is going to just be managing the network. So the first provider is going to be governing the network. So they'll figure out who are the consortium members, how do members enter and leave the consortium. The service consumer is going to be operating the network. So you can think of each organization having an admin who is managing the entities in the network, like peers and orders. But the focus of Composer is really in the business service provider. So the business service provider is like, in simple, it could be the application developer or the architect. So they're going to develop the blockchain application. They're going to define what the information going to be stored on the network is going to be, what are the assets, what are the transactions that are going to be performed, what are some of the applications, how are those applications going to be consumed by the user. So it could be some presentation logic there, and how these transactions are going to be performed on blockchain also. There is also a service consumer, so this might be the end users, right, of your applications. So what are some of the key concepts here? So we'll start with the end user, right? It's always good to start with the end user's perspective of the whole thing, right? So the end user, think of it as they want to perform a specific function. Maybe I'm an end user who wants to transfer balances in a bank account that is maintained on the blockchain. Or I might be looking to trade certain artifacts. Let's say I want the network manages a set of cars, and I want to purchase cars on the network. So maybe there's a presentation logic, and the developer is going to be using that UI, user interface, to be interacting. Or they could also directly call API calls onto the application you've developed. So these end users, the way they interact is they have to be registered or defined in a participant registry. So there are a set of registered participants, and they'll be part of a registry that has to be defined. And who are the set of participants? The legitimate participants will be defined by a service consumer. So they will define saying, these are the set of entities belonging to my organization who should be participants of this network. The business service provider is the developer or the architect. They are going to develop a few things, right? They're going to develop the smart contract logic. So this will define the set of assets or data models that you will define as part of the smart contract. It also defines some of the logic or the business logic encoded as functions. So in Fabric, it was chain code. In Composer, it's going to be Node.js functions. Now, the business service provider, apart from developing the smart contract logic, they might also develop an application on top. So the application could have a REST interface. It has some business logic, and it has some integration logic with other applications that it might interact with, both internal and external to the organization. And along with that, they might also develop the UI layer for it, apart from the application. So the end user can directly use the UI or can call the application through the REST interface. Now, whenever they invoke the REST interface, performing certain function, invoking certain function, this invokes a transaction on blockchain. So there is going to be a transaction registry which tells you what are the set of valid transactions. So this is a embodiment of the set of smart contract functions you've defined. So there is a set of transactions you can provide, you can specify. So that's a transaction registry. The transactions, as I mentioned, are written in Node.js code. There is also an asset registry which defines the set of assets being modeled as part of this business network. So let's take a particular example, right? So let's say this is a vehicle auction. So who are the entities in this whole ecosystem? There could be a developer who is going to architect and develop this solution. There are a set of members or users who are interested in owning vehicles in terms of bidding for owning these vehicles. The vehicle itself, you can think of it as an asset. So there is so if you think of it, and then there is an auctioneer. The auctioneer is an optional entity in this ecosystem. They could, for instance, be responsible for closing out an auction. Right? They might start an auction and close an auction. So that might be what the auctioneer does. So what are some of the key concepts here that we are interested in? What are some of the, let's start from the user itself, right? The user wants to see what are the set of vehicles that are up for auction. So there is a vehicle listing that will say these are the set of vehicles that are available for you to make bids on. So each member can come, see the list of vehicles, pick a particular vehicle they are interested in and place a bid. Before they are able to list the vehicles and place a bid, of course, they have to be registered in the member registry. Likewise, you can say there's a separate registry for members and a separate registry for the auctioneer. So it could be multiple auctioneers as well. So those are the set of members in the network. There's a vehicle listing and there's going to be a transaction registry. So this transaction registry will hold what are the offers that you can make. So when a member wants to place a bid on a particular vehicle, that will be recorded as a transaction. So that will be the transaction registry. And finally, there's a vehicle registry that has the vehicle listing. It has the listing registry as well. So each vehicle might have attributes. All of those will be stored. And when you place a bid, that bid will also be entered into the vehicle registry. So that was just an example to show some of these features. I'll show you some snippets of code as well for you to get a feel of what Composer looks like. But before we get there, some components of Composer. What are the things that you will be developing as a Composer user? So the first thing is you have to develop your smart contract logic. So the smart contracts are, you can think of it as comprising of the following. Right? So there is going to be a model file, and this model file will describe the set of assets. So in the previous example, it was a set of vehicles, but you can think of it as any kind of assets that you want to define. And you're also going to define a set of participants who will participate in this network and a set of transactions. So these transactions are the business logic that will operate on the assets. So in the previous example, placing a bid would be a transaction, whereas the vehicle itself would be an asset. Now, this whole thing you can specify this in a very expressive modeling language that includes notions of relationships. So I can create multiple assets and say there is a relationship between the assets. Let's say if I can define, let's say, a member and a vehicle, and say the vehicle has one of the members as an owner. So that is, the owner becomes a relationship between members and vehicles. Right? So you can define relationships like that, and you can also define validation rules. So on the assets themselves, you can specify validation rules, and these validation rules will be automatically enforced when running the smart contract. Then there are transaction logic, the transaction processors, and this is JavaScript implementation of the transactions. So you can implement them as very simple JavaScript functions, and these will get executed in the blockchain in a decentralized fashion. So we'll also see how that happens. The third thing that you can define is access control rules. So these are like privacy settings saying who can write which asset, who can modify which asset, who can read which asset. So all of those access control rules can be specified in a separate ACL file. So each of these, think of them as separate files that you can write. And the advantage is the models can be reused across different smart contracts and even across different networks. So I can define one model for, let's say, vehicles, and I can actually use that in multiple applications. Maybe there's an insurance application, maybe there's an auction application. All of them can use the same set of models. And all this together, models, transaction processors, and ACLs, all taken together, is what defines a business network. So we'll see that. Now, apart from this developing the smart contracts, you're probably going to develop certain applications and services on top. So these applications and services might create, delete, update, and query some of the assets that you have defined before, right? So these are the application logic that will invoke some of these transactions to update assets. And it might also be implemented inside other business applications, larger business applications, and it could be integrated with other systems using REST services. Then there could be a presentation layer. So this is a front end or the user interface. And maybe there may be several of these applications. Each organization may have its own presentation layer. And it interacts with the business logic using REST APIs. And Composer has a neat way to even generate a skeleton of this presentation logic for you. And it's automatically generated code for you based on how you write your smart contracts. So what are some of these key concepts, right? I talked about model files. The model files describe the assets, participants, and transactions of the business network. It's a very expressive modeling language. It includes relationships, arrays, and validation rules. And all of this, let's say an asset and participants, they're all captured as JSON. So they're all serialized data as JSON. And it can be fully validated by a Composer runtime. So think of the Composer runtime as actually a chain code, a special chain code that's actually running within Fabric, which will interpret all of this logic that you've specified, be it assets, be it participants or transactions. This runtime is going to interpret all of this information that you are providing it. Model files can also be, like I said, shared and reused across multiple business networks. There are access control lists that define the sharing and privacy, and these rules are automatically enforced by the Composer runtime again. So it'll look up for each asset what are the access control rules, and it will enforce them. The transaction processors implement the business logic, business requirements. It's standard JavaScript code, and it's executed again automatically on the blockchain when you're invoking those transactions. All these together forms what we call a business network definition, right? It's called a BNA file, and all these are part of that. So here's an example again of the vehicle auction example itself to give you some idea of what each of these is going to be. So our main asset is here the vehicle. So if you look at it, it's defined asset vehicle. It's identified by a VIN. So this is think of it as a primary key in database parlance. So it's a string. So this is like a standard object. And this hyphen greater than symbol represents a relationship. So this vehicle has a relationship called owner with a particular member. So let's look at what member is, right? So member is a participant in the network. It's a special kind of participant that we are defining. So first we have defined this abstract participant that has properties of email, username, and first name and last name. And the member is a extension. So this extends is a standard inheritance terminology. Member extends user, and it has a single element within it, which is let's say the account balance of that particular member. So how much money do you have in your balance? Of course, you can't bid greater than how much money you have in your balance. You can't place a bid more than that. Auctioneer is also a user, but they don't have any balance because they're not going to be placing any bids. So we don't need any balance for the auctioneer. So the vehicle could be owned by somebody who is a member of the network. Then there is a vehicle listing, again identified by a listing ID. So you could think of multiple such listings. Its identifier is listing ID, and whoever is setting up this auction can set a reserve price. And this reserve price is basically something that says that if the bid is going to be less than this reserve price, then I don't even want to sell my vehicle. Only if the bids are more than this do I want to sell it. So that's the reserve price. There's a description and there is a listing state. Actually, it's not shown here, but listing state is actually of type, it's an enum variable. It's an enumerated variable. So you can also have enumerated variables in Composer. And it's a state, right? The state could possibly take different values, saying this vehicle has been offered on auction. It's on sale in the sense that bids have been made for this. Or it could have a final state saying sold to so-and-so person. Right, so that will be the state of the vehicle itself. And there could be multiple offers that are placed. So each time an offer is placed, initially it will be empty, but each time an offer is placed, it will get added to the array of offers. And it has a relationship to a particular vehicle. So each listing will be associated with a particular vehicle. Again, it's a relationship to the vehicle asset. So this way you can easily think of it as business constructs. So here if you look at it, I've only noted it in terms of vehicles, listing, members, and the placing a bid and so on. Right? So these are all business constructs. I don't have to, there's nowhere here do I have to worry about whether there is a certificate involved, what peer I have to connect to, what channel I have to connect to, and so on. Right? All of that will be abstracted away by Composer and made easier for you. And then there could be transactions. So this is the business logic itself. So here we are defining what those transactions may be. Again, with relationships to vehicle listing and member. So this is an offer that someone is going to be placing. And there are certain functions you can call. So let's say there is a make offer, where a particular member may be making an offer on a vehicle. You will invoke that function to execute that logic. And what that logic will do is will first check whether you are a valid member. If you are a valid member, check the vehicle you are placing a listing on, whether it's open for auction. And then whatever is your offer, it will add that to your offers variable. So that's kind of what the function would be. And you can implement that in JavaScript easily. There could be other functions, like auctioneer, for instance, could call close bidding. After a period of time, they could just call that function to close the auction, and whoever is the highest bidder could be the owner of the will be made the owner of the contract. Now let's look at some examples of how you could define access control in this example, right? Or more generically. Now it's possible to restrict who accesses what assets and what rights do they have on that asset, whether they are able to create that asset, whether they are able to modify that asset, call a particular function on that asset, whether they are able to read it. All of those can be defined by access control rules. It can be very simple, starting from everybody can read everything. So here is that first top example is for that. Everybody can read everything. It's going to have who are the participants. Any kind of sample participant, any participant that follows this is okay. What is the operation? Everyone can read. So that's the read operation. What is the resource? All resources. So it's sample.star. And action is to allow. So you can also say deny there. So you can say deny this particular user access to this resource. So that's also possible. So you can have more complex access control rules as well. So you can say only the owner of a particular asset can do anything with it, or can do, basically they can read, write, modify everything, right? So here again, owner has full access. So there we're going to allow, what is the operation? Everything, right? Read, write, everything. Who is the participant? The participant follows this. What is the resource? It's one particular asset. And you can specify a condition there that says owner is really this participant. So whoever is invoking is actually the owner. So only if this condition is satisfied will they be allowed to perform, will they be permitted to perform that transaction. And you can also have credentials, right? So based on the user's secret that you're using, you can ensure that only certain users are authorized to perform certain transactions. And these access control rules are also available in the playground. Even if you're doing a toy example that you're building, you can check these access control rules out in playground as well. The other features of Composer are events and queries. So with events, this is similar to the Fabric events that I mentioned, right? So again, with Composer events, you can define events on the models. You can define events are emit. So the events are defined as part of the models themselves. So when you're defining your model file, you can say emit this model is this is a particular event defined in the model, and based on the events defined, you can emit them as part of your JavaScript functions, your transaction logic. And business applications can trap these events and perform other functions on top. Right? So this is very similar to the chain code events that I mentioned to you in Fabric. The events include, when the events are emitted, they also include the transaction ID and all other relevant information for you to take for you to do business functions on top. Right? So you will have what is the transaction ID on blockchain that was that committed this transaction, that emitted this event. Now the other thing you can do with Composer is queries. So in Hyperledger Fabric, we have support for both GoLevel DB as well as CouchDB as the state database. So the CouchDB gives you ability to store elements as JSON, as documents, and it gives you rich querying capabilities as well. So if you set up your Fabric with CouchDB support, then you can do a lot of rich queries on the using Composer as well. So you can perform complex registry queries, right? So you can say, give me between this range and that range, give me all the elements in this range. So there are a set of complex queries that you can perform on the assets that you've defined, and they can be invoked from within your application that you're developing. But the only requirement is that you've used CouchDB as the ledger for the underlying fabric. So this is the Composer playground. There's a quick link for you to quickly go try it out yourself. The Composer playground is just a JavaScript interface. It actually does not connect to if you have the option of connecting to a fabric in the backend, so you can have an actual blockchain instance in the backend. But for quickly trying out certain things just to see how application development works, you don't even need a fabric network. So you can do it completely, just simulate things in the browser. So it gives you a way for you to test waters. And it's an easy tool for you to develop Composer models and scripts. It's defined by the application developer. So you can go online easily and you can define your assets, participants, and transactions. You can define your scripts for your functions. And you can easily test it as well by invoking a few transactions against it. And you can also install this whole code, the playground code, on your laptop, and you can do it in your at your leisure as well. You don't even need an internet connection after that. So I mentioned earlier that we do have Composer has support for multiple editors. Here I'm just highlighting the Visual Studio tool, where Composer has an extension for Visual Studio that provides easy development capabilities, right? So it gives you full syntax highlighting for Composer. So in this case, all the things like keywords like assets, enum, transaction, they'll all be highlighted for you for easy use. And it also has abilities for code completion. So you'll automatically complete variable names and so on. It has validation support. So while you are typing out your code, actually tell you if you're making a syntax error or something like that, right? So it gives you validation support when you're defining your models, your queries, and your ACLs. So that's the inline error reporting I mentioned. So while you're typing out, you can quickly get hints as to if you're doing something wrong. You can have control plus space for code suggestions. So you can get snippets directly. And you can also get UML diagrams and models generated automatically, right? So this is available on the code Visual Studio Code Marketplace. You can download it from there, and you'll be off to go very quickly. Creating a end user application. So this, as I mentioned, all the Composer code is in JavaScript. Your transactions and all that are specified in JavaScript. For writing these things and connecting with Composer runtime, you need the Composer client module that's available as an NPM. And Composer uses loopback to automatically generate RESTful APIs for your assets. So for each of your assets, it automatically generates CRUD operations to create, update, delete, modify these assets. It gives you an automatically generated code for these REST APIs. And it also has a way for you to generate Angular 2 code. You can generate both CLI code as well as Angular 2 code for you to stand up a user interface very, very quickly. So once you've defined your models and transactions, you can use these to generate a RESTful API, and then you can create a user interface that calls that RESTful API. So you can go list your assets, you can go create a new asset, you can modify that asset, you can delete that asset. All those, there's an easy user interface that's also generated in Angular 2 for you. So that can be a starting point for you to develop the presentation logic or the user interface for your application. Finally, Composer has debugging support as well, right? So it has the ability, there's something called Playground Historian in Composer that allows you to view all the transactions you've performed. And you can see what happened, when, what is a particular transaction that happened. It'll give you a full listing of everything you've done. And that can be very helpful for you to debug your code. And it also gives you a diagnostics framework for application level traces. So you can, it uses the Winston Node.js logging framework. So as part of your transactions, you can quickly get access to the logs that were generated. So using the debug environment variable, you can set up the logs, and you can go look up a transaction. You can go look up the logs quickly pertaining to that transaction. That'll help you debug quickly. And in addition, apart from just your Composer code or anything that you're writing in your application, it is also possible to get the change code level tracing. So you can exactly see what's happened in the fabric layer as well and you can track what's happening on the blockchain. And all of this is very well documented, so you can go look up Composer documentation and see some of these features and read more about them. So that concludes the first section of Composer itself. So there's a quick video about Composer and some of its features. It's 6 minutes. But if you want to get started with using Composer, I would definitely recommend you to both try out the playground as well as see this about 1 hour lecture. Right? It gives you all these concepts defined, and it gives you even a demo of all of these things. And I would also like to highlight this other very interesting project called the Accord project. It was started by a startup called Clause.io. And what it tries to do is it tries to build this notion of legal smart contract. So what does it make for a smart contract to actually be recognized as something legal? So it's a very interesting project. I would encourage you to check it out. It is closely related with Composer, I would say, in terms of the principle. But here they are specifically looking at legal contract. I would encourage you to take a look at that. With that, next lecture, we'll look at how you set up a Composer network itself. So see you soon. Thank you.